In the next section, we will look at some commonly used exposure assessment strategies and evaluate their effectiveness and efficiency in classifying workers into exposure groups. So the strategies that we'll pay attention to are first, the Occupational Safety and Health Administration, or the OSHA strategy, which is used for compliance purposes in the United States. We will also study the AIHA exposure assessment strategy and see how well it does in comparison. And then finally, I will show you an approach by which these different strategies or any kind of strategy can be quantitatively assessed for its efficiency and effectiveness. So first, the OSHA strategy. When an OSHA inspector comes into a workplace, he or she would make maybe one or two measurements, and on the basis of that, make an assessment about whether an SEG is in compliance or out of compliance. And the strategy says that even if a single measurement exceeds the permissible exposure limit, that is the legal standard, then the workplace is out of compliance. Thus, the strategy involves a simple comparison of each measurement with the PEL. There is no statistics involved in this. At the same time, the OSHA sampling strategy calls for very few measurements. Like I said, maybe one or possibly two measurements. What we'll find is that for this strategy, for any level of exceedance, the probability of non-compliance increases with the number of measurements. And we'll talk about the implications of this. Let us assume that F sub PEL is the exceedance fraction. In other words, the probability that an exposure X is greater than the PEL. In other words, P for X greater than PEL. And N is the total number of measurements. So if you make N measurements, then every single one of those measurements needs to be in compliance individually. So we are not doing any statistics or calculating the 95th percentile. It is a straightforward comparison of each measurement against the permissible exposure limit. If you have one measurement, then the probability of compliance is 1 minus F PEL. And if you have two measurements, since both need to be in compliance, the probability of compliance is 1 minus F PEL times 1 minus F PEL, or 1 minus F PEL squared. And for three measurements, it'll be 1 minus F cubed, and so on, because each one of these individual measurements needs to be in compliance. And so the probability of overall compliance is the probability of the first one being in compliance and the second one and the third one being in compliance. And that's why you get the squared and cubed and to the power fourth and so on. And so the probability of non-compliance, 1 minus F raised to the power N for N measurements. Even if a single one of those N measurements is greater than the exposure limit, then you are considered out of compliance. So the graph on the bottom right hand shows the probability of non-compliance on the y-axis versus the exceedance fraction, that is the fraction of exposures greater than the PEL, or F, on the x-axis. So if you have one measurement, you have the N equal to 1, it's a straight line, and you can see that as exceedance fraction increases, the probability of non-compliance increases. It's a direct 1:1 relationship. Let's look at one particular point along the x-axis. Let's say the exceedance fraction of 0.2 or 20%. So now if you have two measurements, now the exceedance fraction is almost 35%. And if you take three measurements, now suddenly the exceedance fraction is almost at 50%. And if you make 10 measurements, you are almost at 95%. So you can see that if you were an employer, if you were the owner of a business, and you just wanted to show that you were in OSHA compliance, then there is really no incentive for you to make multiple measurements. You are better off taking just one measurement and saying, okay, I have a 20% probability of getting an OSHA citation, an OSHA ticket. If I'd made two measurements, my probability of getting a citation increases to 35%. If I'm like a really good citizen and I want to take lots of measurements, I'm only hurting myself because now my probability of getting a citation is at 95%. So for even small values of the exceedance fraction, non-compliance is highly likely, even for modest sample sizes. And thus, the OSHA strategy sets up a perverse incentive for employers to obtain as few measurements as possible, preferably none at all. And this is because the OSHA strategy compares each measurement with the Pell and assumes that the measurement is in compliance if the upper confidence level of the measurement, defined only in terms of the sampling and analytical error, is below the Pell. And we discussed in the beginning of the course that the sampling and analytical error is a very minor contributor to the overall variability. Except in the OSHA strategy, the role of the sampling and analytical error is enhanced. Next, we'll look at the AIHA strategy. And here, as we have been discussing it at some length in previous lectures, the strategy requires selecting 6 to 10 workers in an SEG and collecting one measurement from each worker. And the basis for this recommendation is a finding that fewer than 6 measurements led to a lot of uncertainty. And we'll show that also a little bit later in this section. And once you have obtained 6 to 10 measurements, we can go ahead and calculate the 95th percentile and see which of the 4 AIHA exposure categories or exposure ratings the 95th percentile most likely lies in. So if it's a category 1, it means that the 95th percentile is less than 10% of the occupational exposure limit, and it is considered a highly controlled exposure category. If it's a category 2, then the 95th percentile is between 10 to 50% of the occupational exposure limit, and it's considered a well-controlled exposure scenario. If it's a exposure rating of 3, that means that the 95th percentile is between 50 to 100% of the OEL, and it is a nominally controlled scenario. And if the 95th percentile exceeds the OEL, it's a category 4, and it's considered a poorly controlled scenario. Before we look into how we can quantify the effectiveness and efficiency of a particular strategy, it's important to define some of these terms. And we have talked about these definitions in passing in the past. Effectiveness. The effectiveness of an exposure assessment strategy is the ability to reach a correct decision. That is, the power of an exposure assessment strategy to detect a clearly unacceptable or clearly acceptable exposure profile. Efficiency, on the other hand, is the ability of an exposure assessment strategy to reach a decision with minimum number of measurements or using minimum resources. And these could be the number of measurements or the total cost in terms of personnel, travel, analytical fees, and so on. And the goal of sampling strategy should be designed so that there is a high probability of detecting a clearly unacceptable group exposure profile. And the overall goal goes to minimize the number of workers whose upper percentile exposures are greater than the OEL. Some more definitions. An employee's risk is the likelihood that a clearly unacceptable exposure profile is declared as acceptable by the industrial hygienist. For a baseline survey, this is similar to the consumer's risk concept that is used in quality control, or type 2 error or beta error that you have studied in statistics courses. The probability of a false negative exposure assessment. An employer's risk is the complement of that, meaning it is the likelihood that a clearly acceptable exposure profile is declared unacceptable. And for a baseline survey, this is similar to the producer's risk concept used in quality control. It is known as type 1 error or the alpha error, and it is the probability of a false positive exposure assessment. Some more definitions. The power of a baseline survey is the probability of detecting a clearly unacceptable exposure profile, and it is calculated as 1 minus the employee's risk. And for termination or reduction surveys defined a little bit later, the probability of detecting a clearly acceptable exposure profile is calculated as 1 minus the employer's risk. A termination or reduction survey is a survey where the group exposure profile is felt to be well controlled or highly controlled, but compelling evidence in terms of exposure measurements is needed before terminating or reducing regular monitoring, or before removing employees from a medical surveillance program or hearing conservation program, or before removing workers from a respiratory personal protective equipment program or some other similar action. One of the earliest quantitative assessments of exposure assessment strategies was published as early as 1981, and this paper by Tuggle critiqued what was then called the NIOSH strategy, and today we call it as the OSHA strategy. And it introduced statistical procedures from quality control assessment. It used the operating characteristic curve to show the weakness in the NIOSH, what we call now the OSHA strategy. This is a figure from the paper by Tuggle, and what Tuggle did was to estimate performance curves for the NIOSH 1977 exposure sampling strategy and showed that that strategy was unlikely to detect clearly unacceptable worker exposure profiles relative to a single shift time-weighted average exposure limit. So in this figure from the paper by Tuggle, the x-axis represents the exceedance fraction for a particular worker, and the y-axis represents the probability of deciding that exposures are acceptable. So let us assume, as he did, that a worker has an exposure profile with a geometric standard deviation of 2. So this is the curve at the very top, which is also marked as high variability, GSD equal to 2. And at an exceedance fraction of 0.25, which is a clearly unacceptable exposure profile, because 1 out of 4 exposures exceeds the exposure limit, Tuggle predicted that the use of the NIOSH strategy will result in the wrong decision more than 50% of the time. This strategy with minor variations has since been incorporated into numerous OSHA single substance standards, and in fact, this is the OSHA strategy that we described earlier. So there are a couple of things that I want to point out in this graph as well. At the 0.25 exceedance fraction, you see 2 vertical lines, double-sided arrows. And so from the x-axis to that point on the curve, that is the employee's risk that we discussed earlier. This is the probability of making a decision error when the exposure profile is clearly unacceptable. And what is the complement of it is the vertical line from the curve to the top of the graph, which corresponds to a probability of 1. So this is the power of the strategy to detect an unacceptable exposure profile. So it's only at around 50%. We'll talk about this sort of curve a little bit more in the next few slides. So what we can do is follow the procedure that Tuggle adopted and quantitatively analyze exposure assessment strategies in terms of their performance. We will discuss quantitatively analyzing exposure assessment strategies further in the next section.